Let's talk about the divergence of the vector and the curl of a vector. So in the previous class we studied what is meant by divergence of vector, what is meant by the curl of a vector. So in this class we are going to study some examples based on divergence, curl, and also the mixed examples of divergence and the curl here. Okay, so let's study. So welcome back. So let's see the definition of the divergence of a vector and the curl of a vector here. So basically we know that if the given function is a scalar function, then we have to calculate the gradient of the function, and if the given function it is given in the format of the vector function. Yes, so in that case we are going to find out divergence of vector and the curl of vector. Yes, so we seen these all things in the last video, and in this video we are going to solve some examples of the working method of the divergence as well as the curl of a vector. Yes, so now look at here, this is what the divergence of the vector, it is del dot f here. So here we are using the dot product of the vector and the differential operator del. After doing the dot product we are getting the value del dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, and your vector function is given in the format of f is equal to be f1i plus f2j plus it is f3k. Yes, so these are this is what your vector function. Suppose if you want to calculate the curl of a vector, then we have to make the cross product with the differential operator del. Yes, so now similarly we have the definition of the curl of a vector, and this is what it's a working method. So means working procedure we are using to find out the curl of a vector. Yes, and also here if suppose the del dot f is equals to 0, if del dot f is equal to 0, then this condition is called, it is solenoidal. This condition is called the solenoidal. Yes, if suppose the curl of a function means a vector function is equal to 0, so means this product is equals to 0, this condition is called, it is irrotational. It is rotational. Yes, so however we know these two definitions, so let's talk about the examples depend on the divergence of a vector and the curl of a vector. So let's solve some examples on here. So write out the first example, it is okay. So let's talk about definition, the examples on the divergence on the curl of a vector here. So write out the first example here. Given that if f is a vector function given by x square I plus y square z plus z square k, then find the del dot f and del cross f. So means we require to find out here the divergence of the vector function and the curl of a vector function. So let's find out this. So I will write first the function f. So f is given the vector function, it is x square I cap plus y square j cap plus it is z square, it is k. Yes, so now first we have to find out here the divergence of the vector function. So now write out first, it is the divergence of the vector function f is equal to be, it is del dot the vector f, and it is given by, it is dou f1 vector divided by dou x, dou f2 divided by dou y, and dou f3 divided by, it is dou z. So now here we have the function, it is in the format of x square plus y square plus z square, and the given vector differential operator is converted in the format of dou f1 x, dou f2 y, and dou f3 z. So now differentiate the given function with respect to, so means differentiate this function with respect to x, y, z. So in this case they are given that your f1 vector, f1 is x square, f2 is y square, and f3 is the z square. Yes, so now here, so del dot f the vector is equals to b. So therefore dou f1 divided by dou x, so differentiation of x square, it is 2x plus it is 2y plus it is 2z. So mean differentiation of y square is 2y and this we have 2z. So ultimately we have the value of dou f divided by dou we have the differential operator 2 into bracket x plus y plus and z. So this is what given the divergence of the given vector here. So now calculate what is the del cross f here. So basically we know that the definition of the del cross f it is. So write down this point by pausing the video. So I will solve the example of del cross f here. So now it is given by the format of, so del cross it is a vector f. It is given by I, j, it is k cap. Okay, and here we have dou by dou x, dou by dou y, and dou by it is dou z it is, and f1, f2, f3. f1 is f2, and here we have f3. So therefore I, j, it is k. Yes. So now here dou x, dou by dou y, and dou by it is dou z. So now put the value of f1. So f1 means it is x square, it is y square, and it is we have z square here. Yes. So now expand the determinant. I hope you know how to expand the determinant. If you don't know, please comment on video. You can get a video link for to expand how to expand even the determinant value here. So now it is, so dou z square divided by it is dou y minus dou y square it is dou z here. Yes, plus minus j cap into bracket. So next cross multiply, it is dou z square divided by it is dou x. Okay, and minus dou x square divided by it is dou z here. Next plus we have k into bracket. So it is dou y square divided by dou x minus dou x square divided by it is dou y. So now here dou by dou y means it is the differentiation of the given function with respect to y as a partial. So means rest of any other functions or any other variables become as a constant here. So therefore when you differentiate z square with respect to y, it will become as a 0. So this value is also 0, 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 this value is also 0. So means the entire your curve of a vector, so means del cross f value it is what it is? It is 0 it is. So therefore the given function, if it is I told that condition is that, so what is that? If del cross f is equals to 0, then we can say that it is an irrotational it is. Okay, so hope you understood the example. Yes, so please write down it. So let's go for another example. So let's talk about the second example here. So here given that the function f is, the vector function is given 2x square z into I cap minus xy square z into j cap plus 3y z square into k cap. Then find the divergence of the vector function at 1, 1, 1. So means they are given here the values for x, y, z. So we have to put that value of x, y, z after the finding the divergence of f here. Okay. So now write down the solution here. So here we have to be right first. So write down the function first. So vector f is equal to, it is 2x square z into I cap minus x y square into z into j cap plus 3y into z square into it is k cap here. Okay. So now this is a vector function. Yes, and therefore here we have f1, f2 and f3 value. Yes. So now here, so I will write here the divergence definition. So divergence of the vector f, it is given by, it is dou f1 divided by dou x plus dou f2 divided by dou y plus dou f3 divided by it is dou z. So I will call this equation as 1. So I can make here direct x. But hopefully some of you are unable to understand how the differentiation done by the given function. Okay, so now here from this equation, so I will call this equation as 2 first, and I will take this equation as a 1. So from this equation I will consider f1 here. So f1 it is 2x square into z s, and f2 is minus x y square into z, and f3 it is given by it is 3y into z square. Yes, so now here we have dou f1 by dou x. So means differentiation of f1 with respect to x as a partially. So therefore here also we have differentiation of f2 with respect to y as a partially. Similarly in the third case also. So therefore differentiate f1, f2, f3. Yes, so differentiate f1, f2 and f3 as partially with respect to x, y and z respectively. Okay, so means one another one we have to differentiate, means f1 differentiate with respect to x, f2 differentiate with respect to y, and f3 differentiate with respect to this z. So now here we have, so dou f1 divided by dou x. So means differentiation of this function with respect to x. So therefore 2 and z become as a constant only. So now differentiation of x square it is 2x. So therefore 2 into 2 it is 4x into it is z. So z becomes as a constant, it remains as it is. So next we have dou f2 divided by it is dou y. So this will become as an, here we have minus. So x and z become as a constant, therefore we have 2x y it is z. Differentiation of y square it is 2y. Okay, so next here we have dou f3 divided by it is dou z. So this value will become as 6y into it is z, because differentiation of z square it is 2z. So 2 into 3 is 6 here. So therefore we got some values for the differentiation of f1, f2 and f3. So now substitute this equation in these values in equation 2. Okay, so I hope you written these all things. I will rub it off here. Yes, so now I will put the values in equation. Put the values in equation 2 here. So in equation 2. So here we have equation 2. So we put the value. So this will become as in 4xz plus, here we have minus 2x yz, and here we have plus 6 it is yz. So this is whatever the divergence of the vector f. So look at here, after doing the divergence of f, here there is no any I, j, k components are present. So means unit vectors are absent. So therefore the divergence of a vector, it is always a scalar quantity. Okay, so now here our example is not ended at here only. We have to find out the divergence of function f. So means vector f and 1, 1, 1. Yes. So now put the value. So divergence of the vector f. Yes. So at where at 1, 1, 1. So means substitute the value of x, y, z as a 1 here. So now 1 into 1 it is 1, 4 into 1 it is 4, and minus into plus it is minus, into 2 plus it is 16. Yes, so 6 plus 4 it is 10, 10 minus 2 it is equal to 8 here. So this is what the divergence of vector function at 1, 1 it is. I hope you understood the example. So please note down the example. Okay, so the third example, it is given by the vector v, it is given x square y into I plus y square z into j plus z square k into z square x into k. So then find the curl of a curl vector v. So here the two operators are done at a time. So means first we have to find out curl of v, then again we have to apply whatever the value outcome from this curl of v. Again we have to apply the curl function then. Okay, so now let's solve this example here. So solution we have. So write down first vector b. So vector b is equal to is x square I into j cap plus y square z into j cap plus z square x into it is k. Yes, so here we have, this is the vector given in the format of v. So this will become as a v1, v2 and v3. Yes, so now first find out what is the curl of v here. So curl of v. So curl of vector v is given by, it is I j k, I j k. Yes, okay. So dou by dou x, dou by dou y plus dou by it is dou z. So next f1, f2, f3, but in this case we have v1, v2 and v3. So I will write the values of v1, v2, v3 as an directly. Yes, so this is the v1 value, it is x square y, this is y square z, and here we have z square, it is x here. Here we have z square into x. So now expand the determinant. So here, so expand the determinant means while you are writing z square x, so means it will become as a dou. So I will write some direct procedure here. It will become as a dou y and z square into x. Dou y into z square into x. So in this case, so I will write here a direct value. Otherwise, it's better. So write down the value. Otherwise, you can able to understand. So here become as a dou z square x, okay, so divided by it is dou y minus dou y square z divided by it is dou z x. Yes, so next we have minus j into bracket here, so this value into this, so means dou z square x divided by it is dou x. Yes, so now here it is minus dou x square y divided by it is dou z. So after that we have to write here plus, so k cap into bracket, here we have dou y square z, so dou y square z divided by it is dou x, and here minus, so dou by dou y, it is x square y. Yes, so now here dou by dou y means differentiation of this function with respect to y as a partial. So other constant, other values are become as a constant here. So therefore, this value exactly become as a constant because here it is 0. Next we have dou z. So differentiation of z with respect to z it is 1. So remained only y square. So y square, okay, minus j into bracket we have. So here remained only z square. Yes. So minus here it is 0. So next plus k cap is into bracket. Here we have dou x, so there is no any x quantity, therefore this become as in 0. So minus we have here minus x square. So after writing the value of, it is minus I cap y square plus, sorry, minus j cap, it is z square minus k cap into it is x square. So this is what given the curl of v. So we got here the curl of v. Yes. So now again we have to be write the value of curl v. Yes. So now I hope you written these all things. So write down by pausing the video. So I will rub it off some values. Okay. So I will rub it off this one. So now here we got some value, it is curl of, it is vector v. So initially we considered the values of this v1, v2 and v3. So I will consider this curl of vector v this as an I will consider this as a c1, c2 and c3 here, because of we require to find out curl v. Yes. So therefore, so curl of it is curl v vector. Okay, so similar operation we are doing here also. So here it is I, j, it is k here. Yes, it is dou by dou x, it is dou by dou y, and it is dou by dou z. So now here f1, f2, f3. values. We have to take the values obtained by curl of V. Yes. So now write down the curl of values at here. So this will, what is the value? It is minus y square. It is minus z square. It is minus. It is x square. So now again expand the value. So you will get the answer for curl of curl V. So therefore this will become, so expand it. So I will write here directly. So look at here, it is dou by y. This is what? X square. When you differentiate x square with respect to y, it will become as a 0 because we are differentiating the given function in with respect to the partially, and here x square become constant when we are treating differentiating with y. So this value I will write here directly 0. Similarly, this value. So this is minus into minus, it will become as a plus. So dou z square dou z. So means differentiation of z square with respect to z, it is 2z. So I will write here 2z. So next minus j into bracket. So this into this. So minus. Next we have differentiation of x square with respect to x, it is 2x. Next we have minus differentiation of y square with respect to z, it is 0. Okay. So next plus k. Yes. So k into bracket we have here. So differentiation of z square, it is 0 with respect to k. Next minus into minus, it is plus. So differentiation of y square with respect to y, it is 2y. So after that simplification we get here 2z into I cap minus into minus, it is plus 2x into j cap, and here we have plus 2y into, it is k cap. So this is what the value of the curl of the vector, it is v here. So means you have to do the curl process in 2 times because here we have the curl of curl. Suppose here another way, curl of curl means we have to do the same process in 3 times here. Okay. So write down this example. Yes. So we'll go for another example. Let's have another example here. So here given that the vector function f is equal to be x into I cap, yz into j plus zx into k here. Then find the value of divergence of curl of f. So means here outer function is divergence and the inside we have curl of f. So means we require to find out first curl of f, then the whatever the answer outcoming from the curl of f, we have to be calculated again for that divergence of f here. So let's do the thing here. So here we have, so this is what our function f. So I will write here the curl of vector f is equal to here. So this will become as an I, j it is k, then so dou by dou x, dou by dou x, dou by it is dou by, dou by it is dou z. So next we have f1, f2 and f3. So f1 it is x into y, yz, and here we have it is z and x here. So now expand the value. So this will become as, so I am going to write here directly. So now here it will become dou by differentiation of this function. So here differentiation of the zx with respect to y, it becomes as an 0 because z into x become as a constant with respect to y here. So therefore its value is 0. So next minus, so dou by dou z. So here we have z as a function. So therefore differentiation of z with respect to z, it is 1, and here multiplication of y is there. So therefore we have y. So next minus j. Yes. So now z into this. So differentiation of x with respect to x, it is 1. So here we have z as it is remained. Next here minus xy into dou z by dou z. So differentiation of this value with respect to z, it is 0 because there is absent term of z. So next plus k is into bracket. So differentiate this function. So differentiation of this value is with respect to x, it is 0 because there is an x term is absent. Next xy. So xy differentiation of with respect to y, it is minus x. It is minus x. So therefore ultimately we have the value. So minus I into j y. Otherwise I will write here minus y into I cap minus z into j cap minus x into it is k cap. So this is what our del cross f means the curl of f it is. So we need to find out the dot product for this value. So dot product for this value. Okay. So now write down this thing. So I will write here the dot product value at here. So because what we are going to find out in here, we are finding the value of divergence of curl of f here. So now divergence of it is curl of it is the vector f. Okay, so this will become. So basically we know the definition for the divergence of a vector here. So it will become as a dou f1 divided by it is dou x plus dou f2 divided by it is dou y plus dou f3 divided by it is dou z. Yes. So now here f1, f2, f3 we have to take from the value outcoming from the divergence of f here, but not instead of taking these values. Okay, because they are provided the value as the function here, but they ask to find out this value. Yes. So curl of the vector f1, and then we have to operate the divergence of that value. So therefore this will become as an dou y dou x f1 value. So from this I can take your f1 value, it is minus y, next plus dou y I will take here minus z plus dou y it is dou z, it will become as a minus x here. So after differentiation of the above equation, so now here y we have, here we have x, so therefore this 0 0 plus it is 0, because differentiation of y with respect to x is 0, z with respect to y is 0, x with respect to z it is 0. So total answer should be it is 0. So I hope you understood the example. Okay, so now write out this answer. Let's go for another example. Well, so let's look into the another example. It is example number 5. Here given that vector f is the value of vector f it is, and here then show that f dot and curl of f. So means dot product of curl of vector f and the f vector is equal to be 0. So here f vector is here, but we need to find out the curl of f here. So first find out what is the curl of f here. So solution. So write down here the curl of the vector f. It is given by it is I, j, and here we have k. Yes. So dou y it is dou x, dou y it is dou y, and dou y it is dou z. So next here we have f1. F1 it is x plus y plus 1. Okay. F2 it is 1, and F3 it is minus x, it is minus 1. Yes. So now carefully understand, because I am doing this example by directly. So direct I am going to be differentiating here. So this value. So I into bracket. So now, so this into this. So now look at here. This is dou by dou y minus x minus y here we have. So while differentiating this function with respect to this, so I am getting the value as a minus 1. So because differentiation of x with respect to y is 0, minus differentiation of y it is 1 with respect to y only. Next minus, so differentiation of 1 is a constant with respect to z means it is the value it is 0. So minus j into bracket. Yes. So now here, so this into this. So now differentiation of this value with respect to x. So with respect to minus x it is minus 1, and differentiation of minus y it is 0. So don't write that value here. Yes. So next here we have this into this here. So now look at here. So dou by dou z, here there is no any presence of z coordinate. So therefore this differentiation with respect to z it become as a 0 plus k into bracket. So k into bracket what we have. So this is, so this it is 0. Next, because 0 1 differentiation with respect to x it is 0. So differentiation of this value with respect to y. So 1. So x differentiation is 0. So y differentiation is 1, and here we have 1 differentiation is 0. So don't write the value. So this is what the value of the curl of f here. So now simplify this. So it will become as a minus I cap, it will become as a plus j cap, and it will become as a product of any two vectors. So what is that? If A vector and B vector is given, their dot product is written in the format of A1 B1 plus A2 B2 plus it is A3 it is B3. Okay, so A1, A2, A3 are the scalar component of the vector A, and B1, B2, B3 are the scalar component of the vector B here. Similarly, they given that this value and find out, means we have to show f dot curl of f here. So means f dot it is curl of it is vector f. So means f1, this is f1, f2, f3, and here we have another value. So likewise a1, a2, a3 and b1, b2, b3. Okay, so means we have to multiply the coefficients of I, j, k from the vector f and from the curl of the vector. Yes. So now a1, what is the a1 value? It is x plus y plus it is 1. A2 value it is minus 1. Plus I am applying this value only. Okay. So plus a2, it is a2 value it is 1, and here so b2 value it is also it is 1. So next here we have a3 value it is minus x minus y, and here we have b3 value it is minus 1. Okay, so we are multiplying the coefficients of I, j, k from the vector function f and the curl of f here. So now multiply this minus quantity inside. So what will happen? So minus x minus y it is minus 1. So here we have 1 into 1 as it is plus 1. So next minus into minus it is plus x, minus into minus it is plus y. So now minus x plus x cancel, minus y plus y cancel, minus 1 plus 1 cancel. So now ultimately it is 0. So here we shown that the f dot curl of f is equal to be it is 0. Okay, so write down the example here. So here given that f is equal to x square yz minus xy, then find the divergence of gradient of f here. So now look at here, the given function is a scalar function. So if you want to differentiate, we have to do the process of the gradient only, because the gradient for only scalar, the divergence for the vector function. Okay, so now we require to find out first the gradient, then whatever the outcome will be coming from gradient of function, we have to calculate the divergence for that. So now first find out what is the gradient of the function. So we have the gradient of f, the gradient of the vector. Sorry, it is not a vector, it is a scalar. It is given by, so I into dou f divided by it is dou x plus j into dou f divided by it is dou z plus k into dou f divided by it is dou z. So now look at here, in the previous case for the divergence we are writing only dou f1 by dou x plus dou f2 by dou z and dou f3 by dou z. But in this case we are writing the given value in the formation of I, j, k values along with the I, j, k values, because the dot product for a scalar it is become as a vector in this quantity. So now so I into s, so dou f by dou x. So it is meant by differentiate the given function with respect to x as a partially treat y and z coordinate as a constant. So now differentiation of x, y, z. So differentiation of x square it is 2x, okay, and keep yz as it is. Next plus j, sorry, here we have another along with it s, so yz minus differentiation of x it is 1, so remember it is y as it is. So next plus j into bracket we have, so dou f by dou z. So again differentiate the given function with respect to it is, sorry, here we have y. Okay, so y means it is x square z minus it is x it is. So plus it is k into bracket, differentiate again f with respect to z. So this will become as an x square y minus it is 0, because there is z coordinate absent and these two become as a constant. Now this is what emerge, so gradient of f here. So now apply gradient of f. So therefore it is divergence of the gradient of f. The gradient of f it is given by. So what is that? Gradient divergence of f it is written in the format of dou f1 by dou x. Okay, so dou f1 by it is dou x plus dou f2 by it is dou y plus dou f3 divided by it is dou z. But here in this case f1, f2, f3 are calculated from these values. So this is what your f1, it is f2 and it is f3. So now I will write directly here. So now otherwise I will write this value at here only. So what I can write here, f1 value. So means dou y it is dou x, it is f1. What is that? This is 2xyz minus y plus it is dou y f2. F2 it is x square z minus x. Next plus dou y it is dou z. So it is x square it is as it is y here. So now differentiate this value with respect to x. So after differentiation we get here 2yz. So differentiation of x it is 1 and differentiation of minus y it is 0. Okay, so plus differentiation of this quantity with respect to x it is 0 because there is absence of y coordinate. So here absence of z coordinate, so this value it is 0. So this is equal to it is 2yz. So this is what your answer for the divergence of gradient of f here. Yes, so write down this example. So we'll go for next example here.